So we're continuing our discussion about how to deal with missingness. And again, missing completely at random is where the cause of the missingness is independent of all the variables in our data set. Missing at random, it's related to another variable. Missing not at random, it's related to the variable that is missing. Now, this matters because as we start to look at how we deal with our different methods, we come with different approaches for dealing with missingness depending on which method, which AI method, which statistical model method we're using. So we talked in our previous video that if we're doing short-term forecasting, we should use the same forecasting method to impute or fill in the missing information to avoid bias, because there are assumptions in the model in terms of the amount of time that you're considering and the amount of variability that there is in the data. So it's better for short term just to use the more of the real data, go back another period, forecast the missing, and then use the missing forecast to go forward. So it's better to maintain that same forecasting method. If you're looking at medium term or long term, you're better off leaving the missing values empty rather than adding bias that comes from with imputing the median or the mean, because of the time component that exists in the data set. So why it's missing is not as relevant with the forecasting. Why something is missing is more relevant when we get into regression models. So with forecasting, because of that time element, if it's medium or long term, leave the values missing. Short term, use the same method as your forecasting method to impute. When you have regression models, if you're caring about the statistical significance, which variables are having how much impact on whatever you're trying to predict, then what we need to do is just drop the missing information. Don't impute, because what you're doing when you impute is you're reducing the amount of variation in that data. You're making it look a lot more static. And so because of that, variables that would be deemed to have an impact are then, well, a bunch of the data now doesn't change, doesn't vary, so that variable must not be statistically significant. So if you're trying to identify which variables have an impact on whatever you're trying to predict and how much of an impact, better off dropping the rows. If your focus is on prediction, identifying what that value is or what that label is, are they going to buy or not buy, how many birds are going to appear in a particular area, those types of things, you can impute. You can impute with your mean, median, or random, depending on what's happening with the reason for your missingness. As long as you have lots of variables, so losing and reducing the statistical impact of one particular predictor variable is not going to have a huge impact on the accuracy of your model. So just keep that in mind. When we look at focusing on prediction, and we'll just go back just to recap here, if you're concerned with extreme values, then you want the median, because that will skew. If you are concerned with, if you're not concerned with outliers, you think that, everyone's kind of in the same range, you can use the mean. If you know for a fact that you're missing completely at random, so the reason it's missing is not tied to the value of the variables in your data set, then you could choose to do random sampling. And if you're going to impute, you essentially are going to encode. You're going to replace the missing information, the NANs, using NumPy to replace them with that information. So that's how we deal with regression. We can impute or we can drop, being careful about the reason for our missingness. If we have a classification models are very much like regression. So a classification model where we're identifying if they're going to buy or not buy is a logistic regression model. At least one of the classification model approaches is a generalized linear regression model. So because of that, because the classification models and regression models are similar, some are the same, not all of them. There are lots of different classification models. So it's just this one that is the same as linear regression. But the other ones, the same thing applies, which is we can impute or we can drop them when it comes to that classification model. So we approach them similarly as we do with the regression, because we're focused on prediction. And so we're recognizing that we can, if it's missing completely at random, we could randomly sample for those missing pieces, or we can use the median if we're concerned about extreme values skewing it, or the mean. With the classification models, the models that we're using, they don't allow for missing information, unlike our time series forecasting models. So you will either need to drop them or impute them. You can't leave them there. It doesn't know what to do if that information is missing. So depending on how many of your records are missing information, if it's a small amount, you might just drop it. If it is a larger amount, then you might impute it. And if you're doing that, then you might want to consider having multiple predictor variables, because if you only have, like, let's say one predictor variable or two predictor variables here, then lower the accuracy because you've reduced that pattern or variability in the data set. All right, that's classification models. When it comes to cluster analysis, we don't have labels. We don't know what group they belong to. So the problem with imputing when you have cluster analysis is that you could create clusters where clusters don't exist, or you could negate clusters that exist because you are adding information that you can't check the accuracy of. At least with the classification models, we could see how accurate the training data was to assess the model, to see if we're still accurate, even though we have less variability from the imputation. With cluster analysis, because you cannot assess the accuracy of the model, and you're using it for exploration to find potential clusters, recognize that any imputation, when you're putting in values, it can create clusters that don't exist or negate clusters that do exist. You're much better off dropping the rows that have missing information or using more sophisticated missingness models in those cases. So now we're talking about, using more Bayesian or synthetic data to help come up with a more robust, more informed value for that missing data. So with cluster, either use a more sophisticated missingness model or drop the data instead of imputing. So our last one, neural networks. Neural networks, the most basic form of a neural network is a classification model or a regression model. In fact, multi-layer perceptrons are either a classification model or a regression model. So if we're looking at these very vanilla basic neural networks, they are classification or regression models, in which case we're focused on prediction and we should impute or drop. So we treat them very much the same. When we talk about neural networks, the difference between a neural network and a more traditional regression or classification model is the assumption that there are these hidden layers of information between the general variables we pick to be the inputs and the variable that is our label that we're trying to predict, or the value we're trying to predict, right? That supervised learning method, we're just assuming that there's some additional hidden layers and relationships in between. So it's a more complicated model. It's able to find patterns the others aren't because it's a bit deeper. That is assuming you're not just doing a multi-layer perceptron, which is, again, just a classification or a regression model. So even for the more complicated neural networks, where we're looking for, like, recognizing images and shapes, when it comes to neural networks cannot handle missing information. You can't just leave it blank. You have to either delete or impute with neural networks because you often have tons of variables and you are tuning the model to figure out the impact in those hidden layers. Imputing with the mean or the median or a random selection is much more popular in the neural networks than with any of these other models. So you're less likely to delete missing information, and you're much more likely to impute when it comes to neural networks because it is looking for those additional patterns and relationships in the data. So just to recap, neural networks, classification models, and regression models where we focus on prediction, we can impute or we can drop. If we are focused on statistical significance in our regression models, we should drop. If we're doing cluster analysis where we don't have supervised learning, we don't have a label, we can't see how well the model is in terms of accuracy, then you're better off dropping or using more complicated missingness models. If you're forecasting, so there's a time component, you're better off leaving the missing values just empty. You don't need to drop the end thing. It can handle that information being missing as it builds the model. Or if you're doing short term, to use the same method you're doing for your short term forecast to impute the missing information.